Hello, everyone. In this video, we're going to look at problem 4 in our section on 3.5 on related rates. So let's read this problem together and then set up the drawing, create our equation, compute the derivatives, plug in what we know, and answer this question. All right, so problem 4 says a plane flying at a constant altitude of 4 miles and a constant speed of 300 miles per hour passes directly over a radar station. How fast is the distance between the plane and the radar station increasing when the plane is 5 miles from the radar station? So to get a sense of this problem, let's draw a picture. So let's say our radar station is here. I'm just going to do a big triangle for it because it's a radar station. Okay, here's our radar station and our plane is passing over it. So here's our plane. So what are we told? That we are told the plane is flying, and let's just draw our ground here. We are told the plane is flying at a constant altitude of 4 miles. So that means the height of the plane above the ground is 4 miles. And a constant speed of 300 miles per hour. So here's miles per hour. It's going 300 miles per hour. How fast is the distance between the plane and the radar station? So we want to know the distance between the plane and the radar station. So this distance, how fast is this distance increasing when the plane is 5 miles from the radar station? So I'm just going to label, make sure we have all of our images set here. So here's the plane, here's the radar station. So we have everything set up now. Let's just put on some labels. So let's let this distance here, the horizontal distance that the plane is from where it originally passed the radar station directly above, X, let's call that X. Let's call this value Z here. So Z is the distance from the plane to the radar station. Okay, so now we have our picture set up. So now it's time to create an equation that we want to use. So to do that equation, let's identify what we've been given and what we want to find. So we are given that the change of X with respect to time is equal to 300 miles per hour. We're told the speed of that plane. So that's the change of X. We are told that the plane is flying at a constant rate of 4, or a constant height of 4. So that means the change of this distance is just 0. And we're told that we want to find so maybe we'll put that in the find category. We want to find the change of Z with respect to time when the Z is equal to 5. So now let's go ahead and set up an equation between the Z and the X. So we see here that what we've drawn is a triangle. So I'll make that more apparent, is a triangle, a right triangle. So we can use the relationships between the side lengths of a right triangle. Often called the Pythagorean theorem, to relate those quantities. So we know that x squared plus 4 squared equals z squared. So that's the equation that we want to start with. So now from here, this would be our step 2. Our step 3 is take the derivative of both sides. So the derivative of the left-hand side would be 2 times x dx dt, using that power rule, plus 0, derivative of a constant is just 0, equals 2z dz dt. Again, using that power rule, and then the chain rule, because both x and z are a function of t. So now let's just plug in what we know. So let's make sure we have everything here. So we know what z is. We want to find dz dt. We know what dx dt is, but we don't know x. So let's first find x. So I'll just do a little aside here. So we are looking at this situation where we are 4 miles above the ground. We know that this hypotenuse is 5 because we know that we want to find how this hypotenuse changes or how this distance changes when the plane is 5 miles from the station. And here is that x that we don't know that we need to solve. So we can set up the Pythagorean theorem, 4 squared plus x squared equals 5 squared. So that means 16 plus x squared equals 25. Subtract 16 from both sides. That gives us that x squared is equal to 9, which means x is equal to 3. So now we have x as well. Check. So let's go ahead and plug in all of those things that we know in step 4. So we have 2 times 3 dx dt is going to be 300. Recall that's the speed of the plane that we are given, equals 2 times 5 times dz dt. So now all we need to do is solve for dz dt. So I'm going to combine some of these numbers. So 3 times 2 is 6, times 3 is going to be 1,800, so 1,800, equals 2 times 5 is 10, dz dt. So now I can just divide both sides by 10, and I get 180 miles per hour is equal to dz dt. So if we want to write a conclusion, we'd say the plane, or instead the distance of the plane from the radar station is changing by 180 miles per hour when the plane is 5 miles from the station. All right, awesome job going through this problem. Be sure to rewatch any parts of this video to help yourself become more familiar with these types of problems. And remember, we need to do a lot of practice to become familiar, comfortable, and skilled with solving these types of problems. All right, keep up the awesome work. You got this.